Hello everyone and welcome to tutorial 7 for basic assembly in kinematics. What we're going to do is we have several parts. We're going to design them and then we are going to start with our assembly. First of all, let's go ahead and start with the first part, which is the slider itself. So PRT, RH, slider V01, and then let's go ahead and select a sketch. So it is a circle centered in a rectangle. So we're going to go ahead and zoom in like this a little bit. And then the rectangle will create it this way. I'm gonna double click for some dimensions and basically the diameter itself, then from here to here and from here to here. All right, so that would help us out. Let's go ahead and start defining. So first of all, always start with the small dimensions so that you don't get mistaken with them. So this is a 5, this is a 5, this is a 5, and then in here this is a, I cannot see this dimension, 10. This is a 10 and this one is a 20. All right, so we can zoom in just to see it. Very good. Now we're going to close the sketch and we're going to extrude it for a dimension of 10. So this gives us our first part. We're going to save it. Let's go ahead and create on the desktop the folder. So from now on, we are going to need to create folders um, for our different elements. So let's go ahead and take a look. Create a parts. Create a folder called product, and eventually we're going to go ahead and get started and start having process. We're not gonna need it for today, but drafts and so on. All right, let's go to within parts and save this first part. All right, very good. Now we have the first part. Let's move on to the next one, which is link 1. Looking into a dimension of link 1, we have a radius corner of 3, 2 circles, both of them. So we have a dimension of 10. The circles themselves, I cannot see where is. So it is showing me a link of 6. So this is what I'm looking at. So I'm looking at tutorial 7. And these are the dimensions. So we have a 10 corners radius. This circle is the same as this one and has a radius of 3 as well. And this is 20 to this point, and all of this is 50 and 10. Okay, very easy. So let's go ahead and create link 1. So start mechanical design, part design, PRT, RH, link 1, V01. Alright, so let's go ahead and click on a sketch. Doesn't matter which plane we select. So I'm going to show you this very cool, which is centered rectangle. When you have something that's going to be centered and it's going to move along from the different sides, you don't really want to like put 17 constraints. One constraint will be sufficient. 50 and the other dimension is 10. Now we do have corner radiuses. So let's go ahead and put the circles first. So we have a circle here, and then we have another circle that's gonna be here. Let's put the dimensions at the circles. So this one and this one, this is a 6, and this is a 6. And then finally, the location of these circles, I cannot see. Okay, it's 20. So basically what we have is from the horizontal to this point we have 20, and from the horizontal to this point we have another 20. Now if you want to change two distances and they are the same, you can click, press Ctrl, select the other one and go to edit equivalent dimension, and we put 20 in here. Alright, then the last thing that we need to do is put these corner radiuses. So we can go ahead and select in here. So I don't know what it is. It's impossible to trim the length. I do want to convert the length. So I'm wondering, why do I want to create this way? I'm gonna go ahead actually and go out of it. I prefer to create those filleted element outside. This is my preference. So I am going to go ahead and exit the sketch as it is, extrude it. Are we given a certain dimension? Let's see. So we're not given any dimension of how much we extruded, so I'm gonna just go ahead and do a 10. Okay, that is a lot. The thickness, the radius of the corner are shown the same. Oh, they're same as part link 1. All right, let's see what's okay. 3 millimeters. Okay, that did look a lot. I did do this tutorial long ago. So now finally I'm going to select my corners, and I'm gonna put a nice fillet of 3 millimeters everywhere and preview. Okay, we're all good. All right, perfect. So we do have our link 1. Let's save that. So we're gonna save it in the same folder, parts, save. Now we're going to do link 2. So let's see link 2. Is there like similarity? Yeah, it is very similar. So I am not going to recreate the wheel. I'm gonna just file save as link 2. When you do that, make sure you change the name in here, or else you're going to have a problem in assembly. So make sure that you change the name also here. All right, let's see. I am going to double click on the pad, on the sketch. So everything is the same with the exception of the circles are 10 inches. So let's edit equivalent at 10 millimeters. So let's put this. And then this dimension is 30. So double click 30, and we have our second part. Easy peasy. Save. Now we have link 1 and we have link 2. So finally we need a fixed part for support. So that's fixed part for support. We could have actually used, you know what, I'm gonna do it. So we can use actually the slider part, and what do we want to call this one? Fixed part or support? So let's just call it support. It's actually where the engine will be. It's actually where the engine will be. So what is it we're doing? This one, V01, and let's call it, I'm gonna call it engine, because this is where the engine will be. Save. Of course, make sure you rename in here as well. Control save. Let's go to the sketch, and basically it's a, so basically this dimension is 10 by 10. So let's make this one 10, and it is already centered. Hey, life's easy. And the thickness is 7 millimeters. So we can click save all, and now we have the 4 parts that we need for our assembly. So let's go ahead, and for the first time we're gonna start using assembly design. So far we have done part design, we've done sketcher, we've done drafting, we've done freestyle, we've done digitized shape editor and generative shape design. Now we're going to do assembly design. So first of all, let's go ahead and name this the right way. Capital PRD for product, RH my initials, and this is first assembly, V01. And what did I not press? I don't know what I did, so I'm gonna go ahead and go to properties again. PRD. Yeah, I don't know what was going on. All right, let's go back to properties, PRD, RH. What did we call it? First assembly V01. All right, cool. So let's save it before by mistake we lose anything. So to go to product, we save it there. All right, now we're gonna start inserting the part. A very, very common mistake is people forget to highlight the product before they click insert. So like, I'm gonna demonstrate it. You put insert existing components and you're like, all right, I'm clicking, nothing is happening. Well, basically, make sure you highlight the part, click insert existing component so that it takes you to integrate those parts. Or in case you forget, click insert existing component and then you can click on the product. We're going to take the 4 parts, integrating them into CATIA. So we have them here on top of each other. File, save all, yes. Now, the first rule of assembly is how to use the compass, which means by this is you have to actually use this element in here, this element, which is the compass, to position things almost as you would like them to be. So I'm gonna right click, click snap automatically, then you press on a part, look how you can move it with the green. So you can move and you can move these different elements. Let's say, so I mean, I'm just playing around right now. I'm not doing what the intention is. Perhaps I'm doing it a little bit, I don't know. So this is approximately what you can do, what we're gonna start doing. Now, what we would like to do is actually place the different parts and the different element in a certain way. So let's go ahead and get started. So I'm going to rotate the view a little bit so that it is more in line with what I desire. We would like link 2 to be close to this element. So we're going to imagine there's an engine in here coming through here. Then I imagine we are going to want a link 3 close to this. Let's go ahead and verify that before I do it. Yes. All right. So I'm going to rotate this a little bit just so that we are a little bit realistic. So now that we have this, I am going to select link 3. I'm going to move this. I'm going to rotate this a little bit. So if this is going to be here, so then the other one is going to go out a little bit like this, and we're gonna have these concentricity, and then the final one, this one looks to be completely flipped. So you can see how I'm manipulating things, and then we move it a little bit like this, but so you are approximately doing how it looks like. And actually you don't really want them to be so close, because you want to be able to click on them in a little bit of time, you're gonna see it, to create the constraints. So this is good for me. So by the way, like when you want to move the compass, you can click on it and throw it away, and right click snap automatically, it won't come back. Let's click save all, and now we're going to start to create the constraints. So within your assembly, you have this toolbar for constraints. Basically, you are restricting the motion that you have. So for example, this is a coincidence constraint. So actually you can click on this axis and on this axis. So these will be constrained, this one and this one, this one and this one. And so actually this is a coincidence constraint, and actually we can put this one and this one. So I'm gonna go ahead and update. So I'm gonna press Ctrl U. You're gonna see how, like, let's say, let's look at the view like on this surface here. Okay, you're going to see how the circles will align. So Ctrl U. Look what happened. All the circles got aligned. Of course, they got aligned in a way that the system can compute it. So once again, where is this here? Like, you see how everything got aligned. All right, perfect. So now the second thing, you don't want the mechanism to move. Actually, let's have fun. Let's manipulate and see what's going on. So this is the manipulation. I'm gonna put with respect to constraint, and I'm gonna put it on an axis, this axis. So basically this one will move with respect to, okay, so before we actually do that, we need to fix a part. So the first thing you need to do in an assembly is say what is fixed. In our case, the engine is fixed in here. So I'm going to anchor this part and Control U. Now this part will no longer move. So click on manipulation again with respect to constraint, this one, and now look what's going on. Beautiful assembly and mechanism. So this is the first stage, but hey, what we want is we want these parts to be in contact as well. So we're gonna click on this face, and we're gonna say, hey, these are in contact, or you can put like an offset 0 degree, 0 millimeters. Control update. Beautiful. This is what we have. We're gonna do the same for this one and this one. So you can put an offset of 0, or you can put a contact constraint. So like this is an example of a contact constraint. Both of them, a contact constraint is an offset of 0. So what did we do in here? That Control U. Did I create it twice? Well, let's see. Where is this manipulate? Here we go. Manipulate with respect to constraint, with respect to the engine. Well, it's working. So you can see what's going on. And let's see it from this side. Beautiful. All right, this is working as intended. So we're gonna click OK. We're gonna press Ctrl S to save everything. And this creates for us the assembly. And now the assembly, we are ready to actually move and start creating the mechanism of uh, what we have. So this is a little bit demonstration of how you do assembly. We're going to need that a lot for the subsequent tutorials. Now let's go ahead and switch to the MU digital mockup kinematics. So this is, so we've done part, assembly, sketcher, drafting, 4, freestyle, Gen 6, 7, and now we are kicking off on the MU kinematics. So the first thing that you want to do in the MU kinematics is understand that we need to create a new mechanism. So basically this assembly that we had, the first thing that you want is you want to say, hey, before you even try to simulate, try to put sensors, try to update, try to put commands, try to put loads, you want to convert your assembly constraints into the mechanisms that we have. So you have to create a new mechanism, that's called mechanism 1, and by clicking auto create, it's going to, in here, show us the different joints that we have. So auto create, and okay, look at this, degree of freedom 1, it's beautiful. We have these different elements, so you can see like this is a revolution joint. Actually, this is the one we're going to click in a couple of seconds, where we're going to press angle driven. So this is all of my different elements. We have a fixed part as well, and we can actually observe different things. So let's go ahead and create our first kinematics. So I'm going to click here revolute, angle driven, and we're going to do it from -360 to 360. We can change that, and we click OK. It says the mechanism can be simulated. To simulate the mechanism, what we need to do is simulate with commands. So we come at this point, we click simulation with commands, and basically we are capable of looking at the simulation based on the angle that we have created. So you see a little bit what we've done. This is a first set tutorial, and There is so much more that we can add and so much more advanced capacities that we can add. I'm just going to show a couple of things that are not in the tutorial, but just to demonstrate them. You can actually plot vector, there is so much you can do. So you can actually decide to observe something. So let's say within this command, um, you can actually come and say, you know what, I want the speed and acceleration. And you can actually place a point. So you can say, you can decide which point you want them to be. So reference product, you can come and select this is a reference product. Point selection, you can say, hey, I want this point to be the one for my sensor. So you saw in here you added the sensor. You can actually press on your simulation and it would create for you. So let's go ahead and put this at, I want to put this at 0. So this is at 0. I want to try to put it back into, okay, so let's put it at this location, insert. And what you can do is put at 0 to make a full turn, and then insert. Let's see if I like, and then you can play it. And actually what you can do is this one, it would loop it. So, ooh, that's moving so fast, stop. So what you can do is, let's delete all of these and actually insert, and then you put another location, insert, you put another location, insert, and you wrap it up, insert. So now at least it will, okay, it's moving so fast. So let's stop it, let's make it move so slow, go back to the start, and now that is too slow now. Oh, actually I did not delete the first one. That's a very common mistake. So let's go ahead and do it. I'm gonna delete all of them again. So you have a first position, and like if you click insert already, it is in this position already. So you have to watch out for this one because we are in the 360. So I'm going to go ahead and I'm going to go back to the command angle, which is on the revolute that is driven from minus 360 to 360. We don't need that, so I'm going to put from 0 to 360. And I'm going to go back to simulation, and we're going to bring it to this point, insert, and then okay, this is too fast. All right, good. All right, hold on a second. Let's verify this one more time, and a full loop. Very good. So we can now do this. So we can do the simulation. So this is continuous now. You can see how it's going continuous, and actually you can see the mechanism in here. Now, let's see the beauty of all of this, because what we have is we have activated some sensors. So let's observe. What is it that we want to observe? So I'm gonna say with respect to this angle, and this is this angle. So this is this angle. So I'm gonna observe this one. We're going to observe the lengths. So basically how it's going back and forth. You can actually put, I mean, let's not observe this one. Let's observe the three angles with respect to each other, all the angles. All right. And this is the sensor observation. This is what we've selected. All right, close. Now we're going to play. So now this is all is you're observing the sensors, so we can pause, and you can see the different values that we have at different times. So basically as it's playing, you can see the values changing of the different points. So this is a cylindrical angle that is not changing. What else we can do? We can actually, that's pretty much it for this first tutorial. We can actually activate the sensors from here. Actually, this is even better. Let's do that. So if we activate the sensors from here, and let's say you can also even, all right, so let's activate the sensors, and you see in here the values, how they are changing. So you can play the values that you want and put the different steps, and look at this. You can click on graphics and have the different relationship between the different angle. So of course you can clear out if you don't want this graph. You can come to this point 0 and say, hey, now I want you to start observing all of this. Let's go ahead and put the, so what would have been good is that if we, and I mean, we can see it a little bit later, is we put a length between these 2 points. So we activate a, where is this icon here? So we can activate a point between these two elements and see what's going on. So I'm going to move this. You can see in here the instantaneous value. Let's activate all of them to have fun. So we can see how you're moving all of it, and then graphics, this shows you the different elements with respect to each other. All right, this wraps up this tutorial. Thank you so much for listening to me.